In this video we will show the diffraction interference pattern produced by two diffraction edges. Unlike the single slit experiment where the edges are on the opposite sides, this time they will be on the same side. The picture on the left shows the same side double edge diffraction. It's produced when both obstacles are on the left side. The light diffracted by the first edge cannot go to the left, hence it cannot interfere with the light diffracted by the second edge. That's why no dark fringes are seen on the left side of the pattern. For comparison, the picture on the right shows the commonly taught single slit experiment, which is basically a double edge diffraction from opposing sides. The interference pattern we see here is also produced by the same side double edge diffraction. But unlike in previous experiment, this time we find dark fringes on both sides of the wall. The central spot is so bright that it saturates the camera's sensor. Let's turn on the camera light. The sensitivity of the camera is automatically adjusted. Unfortunately, the side fringes become too faint to observe. Let's see the apparatus that produces this diffraction interference pattern. It's made of a plastic ruler with a metal strip attached to it. This is the arrangement of the apparatus, seen from the perspective of the laser pointer. You can see some part of the transparent plastic ruler behind the metal strip on the right side. It's slightly less than 1 millimeter wide. Here's the sketch diagram of the experiment. The laser beam hits the edge of the metal strip. It's diffracted to the left and deflected to the right, which can pass through the transparent plastic ruler behind the metal strip. The edge of the plastic ruler itself also diffract and deflect some of the laser beam. The result is a diffraction interference pattern on both sides of the screen. Let's compare our experimental result with the more famous single slit and double slit diffraction interference patterns. We can find an obvious difference between them, which is the width of the central bright spot, compared to the side fringes. Let's add some marking lines on the dark spots of the patterns. Note that the top pattern was shot with the camera slightly to the left side of the central bright spot. The left side looks bigger than the right side due to perspective. The markings make it clear that the width of central bright spot on the top pattern is around 3 times the width of the other fringes. Whereas the common single slit experiment produces a central bright spot that's twice the width of the other fringes. The infamous double slit experiment produces a central bright spot that has the same width as the other fringes. Now the obstacles have been rotated around so the laser beam hit the transparent plastic first before the metal strip. The resulting pattern looks similar to the one before. Let's compare them side by side. Besides some visible artifact, the basic shapes of the diffraction interference patterns are the same. The width of central bright spot in both patterns are still around 3 times the side fringes. I haven't found sources mentioning this type of diffraction interference pattern, so this might be the first one. The next step would be to find a way to explain how it was formed. But that's for another video.